This is IMO 1960 question number 1. The question wants us to determine all 3-digit numbers n, which is divisible by 11, where n over 11 equals to the sum of the squares of all its digits. So let's analyze the problem. On the one hand, n is a multiple of 11. It is a 3-digit number. So it could be written as 100a plus 10b plus c, where a, b, and c are integers. So we call this equation number 1. This could be further written as 99a plus 11b plus a minus b plus c. That means a minus b plus c is also divisible by 11. Now, there are not many integers a, b, and c that lies between 9 and 0 have such a property. We require a, b, and c lies between 0 and 9, where the sum of a and c lies between 0 and 18, and minus b lies between minus 9 and 0. So a minus b plus c lies between minus 9 and 18. So the value of a minus b plus c could either be 0 or 11. On the other hand, we also require n over 11 equals to the sum of the square of all its digits, which is a square plus b square plus c square. We call this equation number 2. Now, from equation 1 and equation 2, we get 100a plus 10b plus c equals to 11 times bracket a square plus b square plus c square close bracket. We call this result equation number 3. Now, there are 2 cases we have to consider, which is a minus b plus c equals 0 or a minus b plus c equals to 11. Let's analyze the 2 cases in the following pages. So we consider the first case, which is b equals to a plus c. We put this equation into equation number 3. So b becomes a plus c, and we expand it out and further simplify. Now we see that 10a plus c equals to 2 times open bracket a square plus ac plus b square close bracket. So it is an even number. If 10a plus c is an even number, we call this equation 4. Then c as an integer must be one of the integers 0, 2, 4, 6, or 8. Now, from equation 4, we get a quadratic equation in terms of a. We try to solve this quadratic equation. The color in pink is the discriminant, which is minus 3c squared minus 8c plus 25. We call this result equation number 5. So from here, we have the possibility c equals 0. If z equals 0 is the case, then a could be either equals to 5 or a equals 0. But a equals 0 is impossible because a is the first digit of the 3-digit number, which must be larger than 0. Another possibility is that z is not less than 0, which is 2, 4, 6, or 8. In such a case, the discriminant, which is 25 minus 3c squared minus 8c, it becomes less than minus 3, and it is negative. So, it has no real root, and should also be rejected. So from case 1, we get one result, which is a equals to 5, c equals 0, and b equals to 5. And n equals to 11 times open bracket a squared plus b squared plus c squared close bracket equals to 550 is one possible result. There's one more case we have to consider, which is case 2. A minus b plus c equals to 11. Or b equals to a plus c minus 11. From equation 3, we put b equals to a plus c minus 11 into equation 3. And expand it out term by term. Now we get 10a plus c equals to 2 times open bracket a squared plus ac plus c squared minus 11a minus 11c close bracket plus an odd number 131. So 10a plus c is an odd number, and c should also be an odd number, which means c should equals to 1 or 3 or 5 or 7 or 9. Now from the equation, which is equation number 6, we can further simplify and get a quadratic equation in terms of a, which is equation number 7. And then we try to solve it. The color in pink is the discriminant. There are a few possibilities. Let's see what happens when c equals to 1. The discriminant becomes 5. However, a equals to 15 plus or minus square root of 5 over 2 is not an integer. So this should be rejected. If we consider c equals to 3, the discriminant equals to 9. And a could be either equals to 8 or 5. If a equals to 8 and c equals to 3, b equals 0 and n equals to 803. If a equals to 5 and c equals to 3, then b equals to minus 3, which is a negative number. So this is rejected. If c equals to 5, the discriminant would be a negative number, and it makes the quadratic equation to have no real roots. So finally we get two possibilities, which is n equals to 550 or n equals to 803. And this is the result.